So everybody get the handout on the addressing modes. So the Logix 500 supports how many addressing modes?
456.
No, that's count. Addressing mode. First of all, what's an addressing mode? What is an addressing mode?
Addressing mode is the way the program specifies the storage area.
Yeah, so basically it's how it addresses. This tells the processor how to address the operands. Everybody okay on operands? What's the operand? No, operands are not instructions.
Those are the registers.
So when we start dealing with operands, we're dealing with numbers. Everybody understand that? An operand is the actual number that the instruction is operating on. So in microprocessor, we learn about operational codes. These are the actual instructions we tell the processor what to do. So when you put an N, IO, N, something in your instruction, that would be represented by an operational code. But when you input that number from an input port or that bit that it inputs is a what? Operand. So an operand are the numbers we actually operate on. So if I add two numbers together, the two numbers that I'm adding together are what? Operand. The answer is a what? Operand. When I input a bit, that's an operand, right? You understand? Tell it how to input the bit would be used by something we call an opcode. Luckily, we don't have to. So when you put an input program, when you say, okay, I'm going to input from input port number 3, that would be an instruction, right? You understand? But when you bring that bit in to a register or something or a data storage location, that number is an operand. So we use addressing modes to tell the processor in the computer or in the PLC how to address these operands. Where are these operands at? So first well, not necessarily. We got what we call immediate addressing. So when I come in on a timer, right? You understand? What's some of the things we have on we have on a timer? Let me find.
Accumulate.
Okay, so we bring in a counter, an up counter. Okay. Now, of course, this is not data, so I'm gonna come up and assign this thing an address, right? You know, a C5:0. Now I'm coming right here, and this says preset. Now, if I come up here and I put 5, and I hit enter, that's immediate addressing.
So the operator,
The operand is part of the instruction. If I come over here and I say B3:0, not gonna work for this, is it? I thought we could preset it with it. So this guy has to use immediate addressing. Oh, let's put in. Let's pull up. I think timers we can use direct addressing. Maybe these are timers are T4, right? that example.
Accumulate. They have to be registered, so would that be registered?
B3, the B3 is a data register. B3 registers, we have B3s and B through B10s. And then, I know math, so we look at the first, source A, that should be source A, by the way, so logical hypothesis. Source A, I use the what? Number A. Source B says B3:0. What's the difference in those two?
One of them is the immediate and the other one is, what's it called? Direct.
Correct.
Yeah, the other one is direct.
So the first one is immediate, because it's actually part of the instruction. The second one is direct, because I'm giving you directions to where the operand's at. You understand that?
Address. To the operator.
Right, I'm giving you the address of where the operand's at. I gave y'all explain these, right? This is not gonna let me use this too. I might have to hook up actually go to a real PLC. No, it won't let me use it. Let's go back to PowerPoint. And let's write down these address and nodes. And I'll bring up Logic Pro, RS Logics and see what we can do. So if we come over here and say immediate addressing, the number is actually part of the what? Instruction. And direct addressing, I got this handout I gave y'all. So what's direct addressing?
Where the store, and we'll see the address.
Okay. Then we have indirect in this one, got right? How do we specify indirect? No.
Indirect is by the brackets.
By the brackets. Okay. So we put our address inside brackets. So what does that mean? Indirect.
It is. Go on. Looking somewhere else.
So up here I might say direct, I might say B3:0. Down here, let's say I say B3 inside brackets, I put B3:1. Yeah, so down here I would let's say out here at B3:0, I have F329. Okay. Well, that would be, this guy would be the what? The operand. Well, let's say out here at B3:1, I have R6:8.
that's the address of,
Yeah, so this says that this location contains the address of that. So we're getting it indirectly, does that make sense?
came from the direct,
Huh?
no, you're right.
This is indirect. And what's the next one? I'll give y'all.
Index.
So index, we might have this, and then we might have like B3:3. Well, this is not this is not the offset. This indicates we're going to use B3 starting word 3 as our index register. The offset is actually, I think I give y'all some examples. So that's what I need to do. I need to make sure we're using the same examples here.
The indirect uses both of the hash and the bracket.
Yeah. Now, these are the address and modes supported by RS Logic 500. What you actually need to do is make sure you find out what PLC you're using, what address and modes it supports before you use them in your program. You understand that? So we can use the RS Logic's 500 programming software, but how many different PLCs are we programming in our lab? How many different PLCs are we, I know you're programming one, but how many different PLCs are available in the lab that we're programming? Two. And they are the SLC 504s, yeah, SLC 504s and the MicroLogic 1000. The MicroLogics are your fixed PLCs or your hybrid PLCs, and then the 500 series are your modular PLCs, right? I hope I got this. No, undoubtedly I ran it at home. I got to do a better job than that. So what do we got next?
Index and direct.
Okay, so let's look at an instruction that uses index addresses. That's what I'm trying to get to. I think I gave y'all some examples. Kind of problems you get to when you work on stuff at home and you forget to upload them. So what we need to do when we use index addressing is we got to specify what we call an offset. So how does it show you do that?
Number,
N7, colon,
Yeah.
bracket, N10, colon, 3, bracket.
I need to look at somebody's handout.
I'm reading it right off of it, so that's all. You read the boxes? Yeah. That's the index, that's indirect.
Yeah.
We got one
It's,
above.
it's hashtag N7 colon 10.
Okay, so this right here would be, this tells us we're using indexed addressing, right? And then this right here is the what? Yeah, this is- Thank you. And then the next one gets pretty complicated. What's this called? Index indirect. And how do we identify that? So we got brackets.
You got hashtag N7.
Oh, sorry. Hashtag N7
oh,
colon
Bracket.
brackets. Okay.
N10 colon 3 colon bracket.
So what would this guy do? I think I got this exactly right.
It's a combination of what I just said. Of the direct and indirect. It resolves the indirect portion of it and then add the offset.
So it's using this as the offset, right? And this would be the index. So where would we find this information at on what? So one thing you need, Allen Bradley and Siemens gives their manuals away free, and they're on a PDF format. So you can go to Allen Bradley, or you can just go in and search for, users manuals for these different PLCs. So the ones that we put on the site, who's I go to get there? These should be the ones that were downloaded. You can download them from here, or you can actually go. Of course, we don't have all the only PLCs that we have are the ones that only manuals we have are the ones that we have. So we have the 1100s, we have the 1000 Micrologic 1000s, and then we have the SLC 504s. So when you look at the manuals, of course, when you handle data, you got to understand these addressing modes. So when we deal with immediate addressing, we're basically dealing with constants. And what's a constant? When we're dealing with programming, a constant is a number that doesn't change unless you change the program. So when we use immediate addressing, those numbers are constants. Because if you want to change your counter to go if you want to change the preset, from 5 to 6, you literally have to go and do what? Change the instruction. All the other ones deal with what we call variables. What are variables?
Stuff you can change without.
These are operands that you can change without changing the program, which is pretty neat. So we inputted information, and that's why I couldn't understand why that didn't work. I need to go back and check. We can input information from input ports. We can okay. So user manuals, and then
So, is that some things like in the PLC, I can make changes without downloading? Like if I change the number on the operand, and I don't have to download it. But then on some of them, I have to go offline to make that change and then download it.
yeah, if you have to make changes without download, then odds are you're dealing with a variable.
Okay.
But if you gotta go offline and actually go into an instruction and make a change, and odds are you're dealing with constants. Of course, I'd have to know the actual situation, right? Usually you'll find these in the instruction set manual. So this is the instruction set manual, and you need to figure out how to do a find for and we'll just look up addressing mode. Okay. So these are valid addressing modes that's supported for this processor. And so we talk about the different addressing modes, but according to this processor, the addressing modes that the 1100 supports are what? So this processor doesn't support index, it does not support indirect. And you can address it down to the what? Bit, sometimes word, long word, or what they call an element.
Now
You
you
can't
got,
do the bid, right? There's no dots.
Yeah, but it's what I'm saying. Yeah, what we'd have to do is go to the actual instruction itself And what we do is we get this chart right here, basically for every instruction. And when you go to an instruction, they'll tell you the address and modes and how far you can address it. Does that make sense? So this is just, and then of course they come in and give you the explanation of the address and modes, hopefully that it supports. So I think it tells you right here that this guy here does not exploit index addressing, but we can duplicate it using, it tells us how to duplicate it using what? Yeah, using indirect address. So we can duplicate indexed addressing, but it doesn't actually support it. And then if we went to the actual RS Logic 500 PLCs, so this guy right here supports what? Direct, indirect, index direct. They're doing it in alphabetical order. Indirect and index index. And then this tells you the registers abbreviations, right? So inside these manuals are a lot of information. These are the guys that actually comes with the PLC. So what we'll do on test 3 is these manuals will be, y'all can use these on test. Not your book, but you can use the actual manuals that come with the PLC. So next time we're in lab, what I want everybody to do is make sure that whichever computer you usually take your test on, make sure that Adobe Reader's installed on that so we can make sure we take care of that. No, you don't have to. It's just available. I mean, you don't have to. No, it's just available. So some of these instructions we've already used before. We've already used the move instruction, right? European instruction to move data from one register to the other, create stacks for storing and retrieving data from the PLC memory. Move data between tables. What is a table, by the way? It's not something you can math. It's not something you read off of. Well, in book we have what we call a table of content. So tables are just where we can just set up arrays or whatever data that we can go in and just pull information out of. When I first got into trig, first time I took trig when I was in college, there was no such thing as calculators that would give you the sine, cosines, and tangents. But that would be something that would be impossible for you to even try to memorize. So what did? We had tables. So what I would do is we look up the sine of 91 degrees, and I'd find 91 degrees, and I would read, you give me the what? The sine, the cosine, and the tangent. So that's the way I took trig. You couldn't do trig without those tables. Now those tables are basically built into your calculator because we use them so much. So now if I want to know the sine of 90 degrees, I go in and hit the sine key, 90 hits sine, and my calculator pulls that up. But where did it get that information from? It's not going to calculate the sine of 90 degrees. It's built in tables. There's tables built into that. So once you get it in the program, so if I want to pull out a bunch of different I/O arrangements, especially when we get into the sequencers, what would be neat if I could just set up how I want to run those outputs in a table, and then just do what? Just go through the table, which is pretty neat, which is what we're going to do. So I'll set up a PLC up here, and we've got a program basically where you can literally program the sequence of a program. Data handling, we're going to use this for reading, storing, retrieving, and writing data into ports or registers, right? Moving or copying data to another register, converting data to a different memory system, especially between like BCD. BCD is a code, right? You understand? But most displays don't work off of binary. They work off because binary. If I wanted to say a motor was running, at 200 RPM, if I send it to a display in binary, it's going to have problems with that. It's going to have a lot of processing power. Does that make sense? So most of our displays work off of numbers, work off a coding system we call BCD. Plus, if I send text to a display, what we're going to do is, I can say the letter A, but how am I going to make my display that? Well, we have codes, and what's the code y'all looked at in PLC still used predominantly? All of them. Starts with an A. Yeah, ASCII, American Standard Code for Information Interchange, which is still in use today, by the way. Even this guy right here uses ASCII. And every once in a while, you'll see when you do stuff, you ever see those percent sign 20s and that kind of stuff that pops in when y'all get a link or try to down something? 20 is an ASCII code for a space, by the way. But even here, when I insert something into this, so what I'm gonna do is I'm gonna oops, I didn't want to do that, Rich. So if you got a chart out and you look at the ASCII code for an uppercase A, I'm fixing that. If I wanted to insert this into my, that's the ASCII code. Now what number system they give? Hexadecimal. What they're doing though is, ASCII code was only an 8-bit code. Originally ASCII code was a 7-bit code. Because what they did is they used the 8th bit, they used that for something called parity. Y'all learn parity in intro. Well, with 8 bits, what they did is that only gave us 128 combinations of characters. What IBM did, it went to a 9-bit code, which gave us 256 characters. So that's ASCII code for the letter what? A. Okay, so if we went to a lowercase a, right here, it's going to be 61. So that's meaning this code is still in use to what? Today. Now what they did is they went to a code called Unicode, but the first 256 codes are actually still ASCII. But then they went to a 16-bit code, so that gives us 65,536 combinations. But the lower 256 are still ASCII. So ASCII code is still a code you use a lot. So if I'm going to send information to a display, odds are we're going to send that information in a code called what? ASCII. But we have to have the ability to do conversions, right? So those strings, when they start talking about strings, those are usually talking about ASCII. We need to be able to go from binary over to BCD, and we need to be able to go from what? BCD over to binary. We can actually see this so we use a lot of what we call thumb wheel switches in controls. Oops. So Logic Pro gives you a set of thumb wheel switches, and here they are right here. And what code does this give you? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it don't go any further. It's BCD. So if I was going to tell my motor to run at 200 RPM, it's going to give me 200 in BCD, and then I'll probably have to convert that over to what? Binary. Okay, y'all understand that? So that means we've got to have instructions that allow us to go between these different codes. to go into string characters so I can send information to a display. Also, which will probably use ASCII code. Get information from thumb wheel switches, which is probably what BCD. Normally these guys here are BCD too. Now these guys right here actually do the hex digits, so they're not actually three. So most of your digital outputs, you got displays on a PLC that tells you the speed of the motor or the counters or stuff like that. It's probably going to be BCD, right? If I input a thumb wheel switch, because an operator, odds are, does not know the hex numbers. They know what numbers it is. Definitely. So converting between these different bases and these different codes, we need to have the ability to do that in our PLC. Where am I at, guys? Right here. Oh, that's still not it. Oh, I went past it again. Here we go, right there. So these are the instructions we're going to look at in this section of the book. We're going to look at move. We've already used that. We're going to look at move with mask. So we'll be able to and mask. Use and mask, by the way, to strip stuff off that we don't want. We're going to look at some stacks, first in, first out, first in, first out, load, first in, first out, unload, last in, first out, load, last in, first out, unload. How to copy files, how to fill files, how to convert BCD, how to convert from BCD, convert from radians to degrees. What's a radian, by the way?
Magnitude direct.
Huh? And we'll look at this and we'll take a break here. So when we start dealing with displacements or vectors, we got two things we can deal with on a circle. We can deal with degrees, right? So degrees would be down here. Okay. But a lot of times I want to deal with actually a physical length. So on circles, when we start dealing with a physical length, what we're dealing with is we're dealing with the circumference of the circle. A line that goes all the way from both sides touches the straight line that goes from both sides, touches the circumference on both sides. We call this the Y. The diameter is if we start from the center of the circle and go out a straight line until it touches this. We call this a Y. So if you take the radius of a circle, and you lay it around the outside, this length right here is called a radian. So we know a circle is 360 degrees, right? But when we start talking about degrees, we're talking about a displacement. When we start talking about physical or lengths, then we're going to deal with radians.
One more time, we talk about.
When we use degrees, we're talking about a displacement. We're not talking about a length. We're not talking about a physical point. Right? You understand? When we start dealing with actual lengths, we're going to be dealing with the actual circumference of the circle. That makes sense?
Degrees of displacement and.
Yeah, so 1 radian is, I think, what, 53.7 degrees? But we're still dealing with degrees. What I'm concerned with is I'm concerned with how far is this length right here? How far would I travel around the circumference if I moved one radian or one radius. Does that make sense? So we could say it's equal to 2 pi times the radius. That's what the circumference will always equal to. What is pi, by the way? Yeah, but where does it come from? So what is pi equal to? You're giving me the number, but how we calculate pi?
Total.
Huh? If you take the circumference of any circle, and if you divide it by the diameter of that circle, it always comes up to give you that. So every circle has the same ratio between the circumference and the diameter. But what we're dealing with is we're dealing with lengths. We're not dealing with displacements anymore. When we start dealing with radians, we're dealing with lengths. Do y'all understand that? When you're dealing with degrees, you're dealing with a displacement. It don't tell you how far it goes. It just says, okay, you're displaced by 90 degrees. Well, how far did you travel if you traveled by 90 degrees in an arc? Well, now we're going to be dealing with radians, right? Y'all understand? So radians is a length. Degrees is just a displacement. It's an angle.
So you would have the, well, say it would be 0 degrees, and you go 90, that would be almost, well, it would be 1.8 something radian.
Well, it's 2 pi rad, you can divide it by, so it'd be divided by 4. So it'd be 1.4 radians. If it's 2 pi rad and you divide it into 4, and you can do this. So what I've got mine divided into 4. So 90 degrees would be 1/4 of this, right? Make sense? Even in electricity, we have formulas where we say X sub L. Now, what we're doing is we're dealing with a length. We're not dealing with a displacement. 2 pi times what we use for the radians, FL. Well, this right here is that's what we're using for the radius. So a lot of your AC formulas, since AC is generated on a circle, when we start dealing with values, not displacement, when we start dealing with values, we're going to deal with radians, right? You understand? But radians is a length. Radians is actually a distance. So if I say, okay, I'm going to go 90 degrees. Well, hey, how far is 90? How far did you go around the circumference when you moved 90 degrees? Well, when I say how far did I go, now we're dealing with what? Now we're dealing with radians. So actually it would be, what did I say? So 90 degrees would be 2 pi divided by 4. Or it'd be 1/2 pi times rad, right? And you could say, okay, this would be what? Yeah, 180 degrees. So that would be, this guy right here would be pi rad, right? Because the 2. When we start, but I need to go, if I need to go between radians and degrees, then we have the ability to do that. So you got to be kind of careful on your calculator when you start dealing, especially when you get into AC. When you start looking at the sine, cosines, and tangents, you're going to be able to give them in what? Radians, or you will give them in degrees. So make sure on your calculator that you come in and you specify that. Okay, guys, you'll take a break. The circumference of the circle divided by the circumference, right? Pi is an irrational number that cannot be represented as a fraction. Its fractional portion never ends and never falls into a given pattern. And this is, I got this off of a person of interest on Harold. I thought that was something. I need to give him every number that has ever been written somewhere in. I thought that was so cool. And I brought up the website where they calculated it out to, this website's only calculated it out to a million variations. Like I was telling somebody years ago, I'd read where they had calculated it out to 2 billion variations. And so this is, hopefully I didn't key this in. I guess I don't know. But this is a million digits of pi. But it don't make any difference. Every circle has this relationship or ratio between the circumference and the diameter, which is what they need. So since AC is generated on a circle, then when you take DC, you're going to deal with radians a lot. In a lot of our formulas. Somewhere, a solid state, when we deal with turning AC into DC, it's going to come into play. Pi is going to come into play. All I got to do now is figure out which one of these that's open is my. There's AC. This is a radian. So, but when we're talking about a radian, we're actually talking about the distance around all, right? If that makes sense.
So is one radian always going to equal 57.3 degrees?
No matter what size the circle.
So,
Because if the circle gets bigger, the radius gets bigger. And it'll always equal 53.7. Always. And then this is what we're talking about. And you don't need to know this. It's just understanding the difference between a radian and understanding the difference between a degree. And we need to go between the two of those, right? In your calculator, when I'm teaching AC, if people throw out these little weird answers all the time when they're looking up the sign of a number, but what they get to do, they got their calculators in radians instead of what? Degrees. So be careful with that. So we talked about this, 180 degrees, and I came up with this. Of course, I've been dealing with this. So pi radian, it's actually 1.5. And you could literally take it and divide it up into any number of angles you wanted to, and you can figure the radians out from that. So I need to have and of course, there's a lot of times that the PLC needs to deal with ours. This is why some of your PLCs support your trig functions, right? Your sines, your cosines, and tangents, because that's when we're dealing with what? When we're dealing with arcs and dealing with angles and all kinds of stuff. So if you got your PLC running a milling machine or something like that, then by George, you're gonna deal with those, right? But everybody don't have to do that. So what I'm saying is that, just don't take for granted that RS Logic 500 supports it, that the PLC you're doing supports it, right? So you need to get the manual on the PLC and actually look at the addressing modes and see what instructions that thing actually supports. Or when you try to download it. Now that's one of the things you're doing when you select the processor. So when you bring up RS Logic 500, the actual program, and you bring up a new program, what's the first thing it wants you to do? Select the processor that you're using. And what do you think that's doing? Well, that's loading in all the instructions and everything that processor supports. And then, of course, when you're dealing with a modular PLC, you have to do what? Well, you have to tell it what size rack you got and what modules you have in each side, in each rack. Well, this is neat too. We need to move on, but this shows how AC is actually generated. So AC is actually generated on what? On a circle. What we call a sine wave is generated in a circle, which is pretty neat. And notice it's just giving you the height of the radius, so it's just a portion of the radius. I didn't do that, by the way. I stole that from somewhere. Okay, so converting between these, the slide says numbering systems, but it actually it's converting between, I think this is the one. No, that's not the one I want. Where's my slide at? I see it up there. Hold on. Here it is right here. So I think we've already dealt with the move instruction, but this would be considered to be a data handling instruction. So the move construction consists of several things. Well, it consists of two things. It consists of a what? A source and a destination. So we're using two move instructions. The first one we're using what? What type of address?
Yeah,
Immediate. Which is using. It's not indexed, it would have a dot. This is direct.
Direct, yeah, direct.
So one of them can be immediate, but one of them's gonna have to be an address, right? You didn't move something immediate. This guy right here, this is using what address? Direct.
Send it to someplace.
This is direct, but this is one of those where we have the ability to select a bit or select an element or a word, right? So here we're selecting a dot. What is the dot mean?
The whole XLR.
Yeah, this means the whole word. So we're going to load N7, whatever N7 is, into the preset. Do y'all understand that? Any questions on that? Which one?
Talk about one time.
Okay. So what we got to understand when we look at the moves instruction, it says one can be an operand, one can use immediate, but the other one's got to use, or it's got to be one of our other addresses.
On the move.
I'm sorry, the destination, let's repeat, the destination will have to be a data location, the register, right? The source can either be a what? Or a register. Go ahead, Larry.
You just answered it. I was gonna say the source would be.
Yeah, well, any address and mode, but the destination has to be, it's gonna have to be one of our register addresses, either direct, could be indexed if it's supported, could be register indirect, right? Are we okay? And we played around with this one. Remember, we moved input ports into places and all kind of neat stuff. It's kind of neat. Any questions on this? Yes or no? Everybody okay? So what's this guy right here going to do? Logic diagram using the index register.
What's that, that destination that moves at 5, colon, 4?
What are we talking about?
Number 5 in front of it, move box, the last box.
First or second one?
Third.
This box right here.
Yeah.
I think that's probably a mistake. Logic, right?
Should be S24.
S24.
And by the way, this came right out of, did y'all say S24?
It says it in the example box.
This guy came right out of the instructor supplemental package. That's supposed to be in this. What is S register, by the way? And what's S24? We ran into that before. Anybody remember? I don't. S24 is a, one of them that we use for different things. Oh, S24 is the index register. So, S24 is the index register. So before I use index addressing, what's one of the first things I need to do with S24? First of all, I need to get rid of some of my PowerPoints. So,
Gotta have a destination.
I still have Logic Pro up and running. Dang it. So S24 is the index register. And I was looking for the place where it told us that. Anybody remember?
So index register, sometimes we call it form, the register that holds the address of the data. Data then is placed in another data register. It's a whole spot. 296.
Yeah, but that's not where it told us that at. This doesn't tell us here we go, it's in example 14-1. Says you will often use the PLC counter for advancing the index register, and then inside parentheses it's got what? That's 24, page 297. Are we in the same place? So S24, which is one of our status registers, this is the index register. So when we're going to be using index addressing, one thing we probably need to make sure we use is what? Make sure we put something in the index register. And what I was trying to do is trying to look at Logic Pro and see what they put in there by file. I think what I'm going to have to do is hook up a PLC so we can actually look at this on a true PLC. So of course, to actually see these status registers, y'all know y'all gonna have to go online, right? And then when you go online, what's gonna happen? So where did this guy right here come from? It just came from the PLC. Right? So as soon as I went online, it automatically uploaded the current program in the PLC. This has happened a couple of times when people have completely lost their comments and everything. And they end up with multiple programs up there because they keep downloading the PLC when they go online if you don't have a program in there. I don't know which one this is, but we'll come over here and we'll look at the status register. I'll look at the status register. So this is the way it comes up with on the status register. Of course, this is S4, which is the this is not a good PLC. Why is this not a good PLC? This is 1100, MicroLogic 1100. I need to get one of the 1000s. Normally your index register is going to pop up on here, but what's the problem is that the 1100 doesn't use index register. What'll happen is the main registers that you use usually pops up on the very, very front list. I forgot that. So what we would get is we'd get another line here that would show us the current contents of the index register. When you go on to the MicroLogic, and you look at the status registers, all it does is show you, it don't tell you which one's the index register and which one's the counter register. It doesn't tell you any of that. It just gives you registers, right? So here, when I come over here and look at the status register right here, it just shows me this right there. And of course, this guy here does support index addressing. So what? Here's the index register right here. It's S2 24. Now, when you bring up your status register on the real PLC, a lot of them is going to drop a lot to 2. Have y'all noticed that? Because these are fixed registers. These are registers that have a function in the PLC. So when we use that counting register, then we can address it without the 2. So if I'm going to use indexed addressing, one of the first things that I'm going to do, and it's supported by the PLC, before I use it, the first thing I'm going to do is I'm going to put an address inside it. Okay, everybody understand that?
So how you put it?
How would we put an address in there? Somebody tell me.
Oh, like getting that address to it.
Yeah, we'd come up here and we'll come over here and we'll just use a bit, right? No, these are 1. No, this is the actual PLC. No, this is Logic Pro. So their input is 1, right? 0. What we would do over here is we'd use a what instruction? We use a move, right? And then what do we want to put in there? Okay. X, and then we can come down here, and then the destination was by what? That's the way we would get something in the index register if we didn't want the default.
Now, this legal one, what?
Is what?
DSD.
I'm not.
Is this legal on Logic Pro or does it have to be S2?
I think, yeah, S is legal on Logic Pro. We did that I think the other day. Well, we could see. So let's come up here and we'll download it. And then we'll come up here and look at that register. We'll go into status register and we'll look at S24. We're already there. Yeah, I thought I had it up. Oh, you switched out of run, sorry. So yeah, it looks like it's fine. But these would only be registers that are assigned that I know. So if you're using one of the S registers that's not assigned, then I think you have to specify the 2. But like the index register, registers that are assigned, like that count register, which is what it is. See, when we access the count register, we don't have to specify S2. You can. Usually when you do it on a regular PLC, if you specify S2, when it pops up, the 2 is not there. And this is true on all the Allen PLCs. Need to figure out on the Siemens. Of course, I'm learning the Siemens myself, so I'm sure it's got one of these registers in there for you. I don't know what it is. So I don't know how to use the actual registers that are available to you. So if I come up here and and I look and used index addressing, which is what this guy's doing. So we're on figure what?
14.
Okay, so somebody figure out what this guy here's gonna do.
We send them, what's in a account accumulator, we send it to the express. So where's the in the stock move function, where are we doing that?
Well, what we're doing is we're using N7 as one of our
So, okay.
sources with an offset of 0. And then the next one we're using D3
Definitely.
as the destination of the offset. Right?
Right.
So if I had 5 in my index register, so this is what we need to figure out. So let's say this S24, so S24, we're going to put a number in it. Let's say it equals a 5. Okay. So what would be the first address? Let's say we came over here and here we put, let's say we put a 2 right here and down here we put a 4. What would be this address? Yeah, this would be N7 : we take the offset, add it to the index register. So this first one would be what? 7. The other one would be inside the B3 and it would be equal to 9. Y'all understand? So I gave you the contents of the index register. By default, by the way, if you run this, you saw what it's going to pop up. It's going to pop up being 0. So, but you got to understand, if it's going to be 0, I wouldn't use the index register. Right? Now, some of your instructions require it. So what we do is we set up the contents of the index register. Then we establish what storage data files we want to access. So we're addressing an address within the N7 data files, and we're also addressing a location within the D3 data files.
But will the bottom move function, will it not just replace whatever's in S24 with the accumulator?
Yeah, but what we're doing is figuring out this first one. Let's don't work down there. Let's figure out index address in first, Larry. That's a good point. Normally, I would put this one at the top. It looks like this one needs to be scanned first. So that's S24. So that's supposed to be an S. So mine was wrong. So first of all, this guy here probably needs to be at the top. We're going to move the contents of accumulator A into our index register.
But I mean, would it not go through so fast that the first box really didn't matter?
I don't know what you mean. These guys are usually scanned in sequence, so I think this guy right here should be on the top. Because what it would probably do is this one, and this one. Now the next scan would probably, I understand, yeah, the next scan would be fine.
You can't get the accumulator yeah. So it's got to do the count first.
Yeah, but what Larry's saying, it's going to be enabled all the time, and if I have this push button, it's going to be ripping through the scan time of the processor. So what Larry's saying is that we wouldn't even see the first time through the scan, and after that it would be right. But if I was doing the programming, I would do what? This guy here would be first. But it would happen in a heartbeat. That's like sometimes when you wanted to make the light break, when you wanted to make the light blink 3 times, you reset it on 4. and you never saw it, right? Because it was what? Well, it's instantaneous. But normally, what I would do is I would move that first. So what they're doing is they're taking, I'm just giving you the content. So let's say the counter's got 5 in it. Okay. So that would come from this counter. Whatever's in this counter here, in the accumulator of this counter, is going to be put into our index. So what we specify in index addressing is we don't specify the address, we specify an offset from an address, right? So first of all, we specify the data registers we're going to be using. So N7 does not specify the address. N7 specifies the data registers we're going to be using. We're going to be using integers, right? You understand? Yes or no? So all this information is going to be stored somewhere in N7. Then we specify an offset, right? You understand that? So what the actual offset would be is that we take whatever's in the index register, we add the offset to it, and then this is going to give us our word. Everybody okay? So what I'm doing is I'd say N7:2. Well, that 2 is not the address, it's a what? Offset. Okay. What are we offsetting from?
Yes.
We're accessing from the index register. So what would happen is if I incremented this counter every time through the loop, then the first address, we start off with 0, and then I incremented the counter every time, right? You all understand that? Then what's going to happen? Well, my first address would be N70. Next time through the loop, it would be what? 1, 2, 3, 4, 5. So we're stacking these guys up out there, right? You understand? Yes or no? And then what could I do? Then I could come through it. I could either go back to the top and come through it this way, or I could come from the bottom and come from it that way, right? Instead of getting the data back off the stack. So if we did what we call a LIFO stack, like that sample,
That's the inverse.
that's the first stack.
Whatever you top is that.
Yeah. So whatever went on the stack last, so we would just reset the stack and then we could come back to those operands in the same direction. Or I could decrement the stack, which means we go down 1 each time and come from the bottom back to the top, right? First in, first out, and that's what they're looking at. So index addressing gives us the ability to go through tables. Y'all understand that? So here before long, we're going to get into sequencers. And sequencers did I show y'all that? I don't know if I can find that drum switch. A drum switch is a switch that has multiple storage locations. No, that's not the drum. That's not the sequencer drum switch. The sequencer drumsticks that I've got is you got metal tabs that you can arrange. And I forgot how many of them there are. And I need to find that. And every time you move the drum switch, it makes a different set of contacts. But what can you do? Well, you can go in there and manually change those contacts. So you could have 6 positions, and you could literally program what you want to do for each 6 of those positions. But the problem is it's mechanical, so what would you have to do? If you wanted to change the sequence that these motors are, you'd have to go in and move the tabs. You'd have to break it apart and put the tab through. But a PLC goes through tables without any problem. So I've got a program where we literally can program the motors when I come back up, where we can run them in any sequence we want to. We can turn the lights on in any sequence we want to. And basically we're saving those on the stack. It's really cool. And, so you would have a programmable sequence. So you could set up a sequence different for different parts. So all you do is say, okay, I'm running part number 37, and you could load in a different sequence on how you want to run those modes, right? Does that make sense? Yeah, so normally I would put this guy here first, but like Larry's saying, the sequence would be so fast that you would never see the first scan.
Slow it down.
No, in a real PLC. On a real PLC, you cannot change the scan time. Everybody understand that? So that's set into the processor. Logic Pro allows you to change the scan time. So you got a little wall. You got a little scroll bar up there, a little, I think that you can change the scan time. And what they're trying to do is that most of your aspects of Logic Pro is set by the computer that you're running. So I think I told y'all that, I've got a monster of a desktop at home, and I'll set the timers and stuff, or not the timers, when I use that S4 register, it'll be just fine. I come here and put it on this computer, everything's so slow because this computer does run slow. So we can't change the scan time on an actual PLC that I know of. So that's index addressing. And the index register is a fixed register. You cannot assign the index register. It's always S2:1, 24. You can address it. You can address a bit if you wanted to. You can mask it, so you can treat it like a storage location. But if I use index addressing, if I put that hashtag up there, then that next number is considered to be the what? Offset. And what's it going to offset from? Yeah, the index register. The index register originally starts with 0, but you can load it with anything you want to load. Okay, mask. Everybody understand what a mask is? When we mask stuff, we cover stuff up, right? Does that make sense? An OR mask will mask it with a 1. So that means whatever, it don't make any difference what the other operand is. If I have a 1 in the OR mask, I will always come up and get a 1 in the answer. Everybody understand that? An OR mask. So OR mask, we mask with 1. Mask means we cover up the original number, right? You understand? So if I in an OR mask, if I put a 1 in my mask, the answer is going to have a 1 no matter what variable I'm bringing. Everybody understand that? So that means if I came over here and did an OR mask, so normally we use an OR mask to make sure certain bits are set. I could come over here and use this for an OR mask. And my answer, no matter what, this would be a 1, this will be a 1. I'm going to put an X right there because that one's going to depend on what? The other number that I'm ORing with. This would be a 1. I don't know about that one. This would be a 1. This would be a 1. This would be a 1. This is going to depend on the other operand. This would be a 1. This would be a 1. This would be a 1. This is going to depend on the other operand. And this would be a 1 and this would be a 1. So an OR, we cover up the other bits with a what? With a 1. Now, AND mask, let's say this was my AND mask. This is not the same one, guys. I'll just make up another. Let's say 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Well, what would this one be if this was an AND mask? We don't know. It depends on the other operand. Right? You understand? What would this one be? This one would be a what? A 0. I don't care what the other operand is. Because if I AND anything with a 0, the answer will always be a what? A 0. If I AND something with a 1, then it's going to depend on the other number. So what we do with an AND mask is we're going to make sure that certain bits are cleared. We can use an OR mask to make sure certain bits are what? Set. So we've got this guy right here. So a mask, we got move with mask. What kind of mask do you think this is? Is it going to be a hand mask or an OR mask? It's going to be an AND mask. So let's say we want to, what can we load in from an input port? We got two options with an input port. We can either load in a bit or we can load in a word. That's the only two options we got. That makes sense? Well, what if we wanted to just load in a bit? How would I get rid of those other bits? I'm going to change these back over to switches. Because that way we can. Okay, so we know over here in this move instruction, what can the source be? Let's take it back on something. Okay, so let's say I come over here and I go input, what, 1:1.0. Okay. And let's put it somewhere. Let's put it out. 2:0. 2.0. Okay. Now, of course, what's going to happen here, if I come over here and I do this, right? And we'll run the program, we'll download it, and then we'll run the program. And, so what happened, of course, notice that the output's duplicated in. Now let's say I don't want to do this. I only want to bring in the first 8 bits. Well, what I need to do is I need to strip these off. So how do I strip those off? We could do an AND mask. So what I could do is I could move it and then I could AND it. But we mask off, we use probably the most predominant mask that we use is we use AND mask a lot more than we do OR mask. So I could do it with 2 instructions or I could do it with 1 instruction. So what I'm going to do is I'm going to take this guy here offline. I'm going to delete this guy. And instead of using a move, I'm going to use a move with mask. Okay, my source is, I'm going to move it over to the other input, by the way, because guys, I'm going to say n:, okay, so we're getting it from input port 3. What do we want to strip off? Which ones y'all want to strip off? Okay, so I'm going to put 00FF X. Okay. And my destination, we'll still put it in output 2:0. Oh, not 2 dash. 2:0. So 00FF, so what's it going to do? It's going to strip off the upper 8 bits because it's an AND mask. So in an AND mask, if I've got a 0 in my mask, it don't make any difference what's coming in on my other operand. Them guys will be stripped off. I'm getting it from the other port, by the way, because I'm using the first one to load it. What addressing mode is this? Direct. So we'll come up here and just randomly put some numbers in here. And then what we'll do is We'll upload this and we'll run it. Okay. And we'll come up here and close the switch right here. Now what happened? So these came through, right? Over here. These came through. But what did we do with these? We masked them off.
Okay, now how, I'm just missing something. How did you mask the FL?
Huh?
How is FL? I don't understand that. But I know it's 15.
Well, we're not, when we talk about mask, we're not talking about numbers. We're talking about bits. Okay. So what we've done is we set up a mask of what? 0, 0, F, F. Well, in my answer, these are going to be zeros. They're going to be zeros. Okay, you understand? What are these? These are going to be whatever comes in on the other operator. So that means I came over here, and let's say over here I got this right here. It don't make any difference. I put everything. And down here I have this. So what are we going to get on the output? Well, up here I'm going to get what? Zeros. Over there I'm going to get this. I'm going to get what? 1. I'm going to get this. I'm going to get 1. Over here I'm going to get this. And I'm going to get this, this, this. Well, these are the position of those switches. So you're trying to look at it as the number 15 or the number 255. But when we're doing mask, we're doing them on a binary level. And it is a bitwise right logic. So that means we're doing 2 bits at a time. So we're bit 0 with one operator is being and with bit 0 of the mask. And that's why when you put those ands and ors, it says bit. If you ever notice, it says what? Bitwise. So
you got to mask the first bit. And work your way back.
Yeah. So if I wanted to find out if bit 7 right here of this input was set or clear, then I could just mask off the other bit. I mean, if that's the only one I wanted to look in. But what we have the ability to do, especially with these masks, is we have the ability to deal with a whole 16-bit input port at the same time. So instead of me coming up here and pulling in 1 bit at a time, we can do what? We can bring in the whole port with 1 scan. So if I tried to bring in 16 bits, 1 at a time, that would be 16 runs, and I would be scanning 16-bit runs. Right? You understand? And then we don't need outputs for them. You know, we might need an output if this and this one said, or this one said. Well, what we can do is we can mask off what there. We can mask off the bits that we're not concerned with, and only keep the bits that we are concerned with, which is really, really neat. And so this gives me the ability to make a decision. So I can say,
So
okay.
your 0 is doing the mask without the FL.
Well, no, both of them's doing the mask. And that's what I'm saying. Even when I put on the mask, it's got holes in it, or I walk in the
So
wall.
I mean, by designating a high,
We're letting the other bit come through.
right? So
It's not stripped off.
then the 0 is
The 0 actually strips it. So instead of masking, I would probably use strips, strip them out.
okay.
Because all of it's part of the mask. So what bits on the mask I wanted to come through, we would put a 1. We would put a 1. What I wanted to strip off, I would put a 0. But they're all part of it. Yeah. So it's just a terminology. That's just what I would use. Because on a mask, even when you wear a mask, you know, we call it a mask. You don't cover up everything.
Right, but the 0 is what makes it.
Yeah, it strips it off.
Gotcha.
Okay, guys, let's take a break. I'm going to pass my break. 10 minutes. Just like when you go order Chinese food. Right? How long is it gonna take? 10 minutes.
Man, bother them.
Don't need it. That's gonna be our drinking water.
Tell you what, better be careful with the rules.
Okay, guys, I'm trying to hook up my PLC. And what we're trying to do is, normally, but we don't have to do that, is normally we hook up our inputs as syncing. Now, if you buy a modular PLC, you're not going to have the option. Everybody understand that? So a modular PLC, you buy syncing inputs or you buy sourcing outputs if we're dealing with DC. AC, so syncing and sourcing only comes into play if you're dealing with DC. Everybody understand that? So normally we hook up our input syncing, and then if you look, we hook up the output sourcing. So what does that mean, guys? What does that mean? So I got my input. So on the Micrologic PLCs, you don't have the ability to hook up all your inputs as syncing or sourcing. What they do is they divide them into groups. So this one has 0 through 3. 0 through 3. Input 0 through 3. I need it. So input 0 colon, I'll get this right. Input 0, right, slash 0 through 3 has a common. And then the other group would be input 0, 4 through 9. It has a common. So if we want to hook them up syncing, what do we need to do? So your fixed PLCs has a internal power supply. Your modular PLCs, you have a power supply module you buy. Or you can use an external power supply. Okay. So when we go over there, when we was over there on the 914 Siemens that we had over there, they had an external power supply. The Micrologics have a DC power supply on. So the inputs are DC, 24 volts, which is standard. So what do we do, guys? If I want to hook them up for syncing.
Negative.
So if we look on the same side, we have a DC power supply, and then we got one terminal that's labeled plus, and we got the other terminal labeled minus.
Negative. Goes to common.
Okay, well no, there's no ground.
The negative.
And when we're talking about syncing or sourcing, we're not talking about what we use as a ground. We're talking about what we use as a common.
Power supply negative. Goes to common.
Okay, so what we do is I'll take power supply negative. I'm gonna hook them up, and I'm gonna hook this up to the common. And they don't say they say DC, and they don't say ground. It's called DC-COM. That's what common. And then over here, the other set, I've got a jumper that's going to jump over here to its what? DC common. But you don't have to hook up both of them syncing, both sets syncing. You can hook up one sourcing if you want to, or you can hook up. You decide what you're going to use for common. Everybody understand that? Yes or no? Yes or no? Okay. Now, if you want, but remember, if you use a syncing input, the device you hook up to it has to be a sourcing device. Y'all understand that? Yes or no? No. If I hook up, we're talking inputs right now. If I set my PLC up to sync, then my device I hook up to has to source. Y'all understand that? So every circuit's gotta have two connections. We gotta have a common. So the input is the load. So the input is the load. So I've got all these input ports over there. I'm gonna draw its boxes. And what I just did is I made negative common. And I've got the commons connected together. But I need to have current flow. Right? You understand? Yes or no? So I've got these jumped together. In fact, that's not the way it actually goes. And we got two commons. So what's it looking for? What's got to come in on this side right here? Power. Okay. So I'm going to come up here and I'm going to hook up, let's say we hook up a bunch of push buttons. Well, what's got to be common up here? Power. So I got to hook up the plus there. And then I would run that plus over to here, right? You understand, to the next button. Well, this, if we hook up, if we use, so the push buttons are using positive as their common. The inputs are using negative as their common. Y'all understand that? So that means if I'm using a sourcing, if I'm using a syncing input port, then my device has got to provide the source. So we say those guys are sourcing. My inputs are going to what? Sync. So this is a common. A common is just a sum that we use for a common connection for all the devices. So that means if I have a syncing input, then every device that I hook up that's going to have power applied to it. Okay, y'all understand that? Okay, does that make sense? We're going to have plus applied to it. So if I have a sourcing output, that means I'm going to use the positive DC as a common. My devices are going to have to be hooked up syncing. So that means all their commons will be connected to negative DC. Right? I understand. So syncing means we use negative for the common. Sourcing means we use positive for the common. Y'all understand that? Because we can program PLCs all day long. But if you don't understand how to hook these things up, you're not going to be any good to anybody. Right? You understand that? Hey, Rich, we need to put another input out there. Well, if I use negative DC on this guy and I have negative over here, I could sit there and hit that button all day long and nothing's going to walk. It's not going to happen.
Now, on module PLC, you buy the power module, will it stay? Is it obvious to sync?
Yeah, we went down there. If you look at the 504s, the SLIC 504s, if you look at the input module, it says it's syncing. If you look at the output module, it's written on the module, it says what? Source. So you don't hook the power supply up to those guys. They get it through the bus that runs down the backplane. So your DC power supply runs down the backplane. So on a module PLC, you specify what? You buy the modules to either be a what? Syncing or sourcing. You understand that? Now what about AC? Yeah, I don't care. AC has no polarity. You establish a common and neutral. Of course, once you establish a neutral, you stick with that. This guy here, we have to establish one of the AC lines. Of course, normally, so this guy here has relay outputs. What's nice about relay output? It don't matter if you use AC or DC. Doesn't matter. Don't matter. You look at the contact rating. Most of them will run up to like 440 volts if you use an AC. And then another thing you need to look on your outputs is the current rating on that pump, right? So if you look at here, I've got a common wire. So I'm going to hook these up syncing. So what do I need to do? Well, I'm going to get a black wire. This is my, so here's the minus DC, if y'all can see that. Then I've got it running into this common, and I've got it running into the other common. Y'all come up here and look at the other. Y'all come on up here.
Which one are they? This one?
Yeah. Them kids got there, they had no idea what a circuit was. They knew a schematic, but they didn't know what a circuit. And so when you get in here and actually physically see these things wired up, drawing those connections on a little diagram is what? It's not the same. And you really, really need to understand syncing and sourcing, because if you get into a plant that's fairly new, they're going to use DC inputs. They might use AC output, but they're going to use DC input. And I know that's kind of off the subject matter, but that's very, very important. A move with mask. Anybody got any questions on move with mask? Or mask move is what they call it. What type of mask does it use? Use an and mask. So basically what we do is we simplify. We can do something with one instruction that would usually take two.
So in Logix Pro, how can you tell if it's an and mask or a normal mask? Or can you tell?
Well, if you use a mask move, it is an and mask. If you wanted to do an or mask or an and mask, you would do it with an and or instruction. Make sense, sir? Yeah, this right here is all we do. And is by far the most predominant that we use. And this is why you really need to understand hexadecimal, because this gives you the ability to see the mask. If you use decimal, you're really going to be in problem. Because it's not a decimal math, it's a binary math.
When you look at it in a mask, to me, it's more like a code. Because really you're not tying them together, you're just signifying which bits are active or is mask active.
Well, you could do a weighted number. If you was really, really good and you could do binary to, you could do decimal to binary in your head, you could put the number in decimal if you wanted to. You could put the mask in decimal, but it's not a decimal mask. It's a what? It's a binary mask.
That's the reason I said I look at that more like a code rather than
First in, first out. Last in, first out. So what we want to do, if we want to keep up, we want to keep up with a table or keep up with things that goes on. A lot of times we'll use this stack, these first in, these FIFOs and LIFOs is what we used to call them. First in, first out, last in, first out. So what we're going to do is we're going to designate what we refer to as the top of a stack. And then what we're going to do, using these index addresses and other things that we got, we have the ability to automatically go through consecutive addresses. And they have to be consecutive addresses, guys. But what we do is we establish the top. Everybody okay? And then we can offset from there. But by incrementing the index register, we can automatically do what? Don't know what increment, what's increment mean? Increase by 1. Decrement means what? Decrease by 1.
This is our S2 register.
One of the S2, it's S224. So the S2 register has a lot of stuff in it. That's where our counting registers are. I think that's where they keep, with a PLC that supports a real-time clock. I think it's up in your S2 registers. The index register is up in your S2 registers. So there's a lot of stuff in your S2 registers. So I think S2:4 is that what? Is that clock for you? So the index register is what? Yeah, it's S2:24. A lot of your instructions, like your counters and stuff, use the status register to keep up with the status bits, your done bits, your, your, what's the other ones for counters? Counter done, your enabled, those are overflows, all those are up in your status register. Are we okay? So if I can start off, so last in, first out, what would that mean? So let's say I come up here and I put a lot of numbers on, and I come down here and do this, and I'll just make up something. So Right now, 35 would be my last in, right? So what would be, if I pulled it off the stack, which one would be the first out?
Which one you going, first in, first out?
Now, let's do it, so, let's see, last in, first out, then it would pull what? 35. If I use the first in, first out, then it would pull 24. Make sense? So this was the first in. If I use a FIFO, then the first in would be the what? Yeah. LIFO would be the what? Last in, first out. Does this make sense? Right. So we've got instructions that we can deal with the stack. We can do it with single instructions. First in, first out. So we need to have the ability to load something on the stack. And we need to have the ability to pull stuff off the stack.
When you create the stack, does it go sequentially?
It will go sequential addresses from the top. So if you pull stuff from the stack, it will decrement it, right? You understand? You push stuff on the stack, it'll do what? Increment. Everybody okay?
No, okay. So you saying 35? Okay,
That
we
was the
stacking
last one.
up. We stacking up now.
Yeah, so what
Okay.
happens, it depends.
I'm
So
looking
this,
at stacking
I
up.
started, yeah, but I started
Yeah.
here.
Right.
Okay, so this was the first in, right? This would be the second, this would be the third, this would be the fourth. Okay. So 35 was the last in.
Bad.
24 was the first in. Okay. Now it all depends on how you put stuff on it. So that means each one of these is gonna have two instructions. One of them we're gonna use to pull, the other one is to
Push on to.
and those are two terms we use. So pull means we're gonna get stuff off the stack, push means we're gonna put it on. So we're okay, everybody okay so far? Well, if you're not, we're gonna do it. The book does a pretty good job of this. Concept of storing and retrieving pallets is a stack in a PLC or computer terms, a group of consecutive data registers or storage locations or words placed temporarily in a memory location or a buffer or go between. So it's consecutive addressing. By the way, you can access the stack with any addressing button. It's just that if we use the stack instructions, they're going to be sequential, right? You understand? They're going to be put on there sequentially, and they're going to be pulled off. Everybody okay? Make sense? But it's got an address. So if you need to get the fifth data off the stack, you can just say, you can use one of your direct address, and then you can go in and specify the fifth address on the top of the stack. So the stack is addressable by any address.
What if you don't address it?
Well, if you don't address it, you're going to use a push instruction or a pull instruction. And that's what's so nice is that if you use a pull instruction, it's automatically going to pull stuff off the stack. And once you pull off this one, it's going to automatically go to the log, to the next one, and be sitting there waiting on you to pull. But what I'm saying is that it's nothing but addresses. If you need to get into the stack somewhere, you don't have to use a push and a pull instruction. You could use direct addressing, right?
You said you can use, it is addressable by all ones?
Yeah, by all of them. Now, we don't do that often, but I just want to let you know you can get into the stack and get in any location off there you want to. Normally, we use this thing and let the processor automatically control the address. So what are our instructions? We're going to have probably 4. So this is what they're doing here. First in, first out, first FIFO and LIFO. And I don't know where this guy came from. This is in your book.
Yeah.
So the top one, we're putting stuff in this side, and then we're taking it off this side.
Right.
Okay. So what would this be?
First in, first out.
So whatever came into this side first is gonna be the first one out of this side. Now this one, what do we do?
Taking off the last.
Yeah, we'll push them down, so here's the last end, we do the one.
First out.
What? Yeah.
What'd you say, Vincent? This looks simple. That's a good diagram. So what happens when stacking data? Stack grows larger as data's being placed on the stack. And the stack grows smaller as you have to manage the registers. Because you're going to only have so many places you can put this, right? Normally, how many addresses do we have within a range? 256. Remember zero, we can actually put something at zero. So you're going to have to keep up with the stack. I don't know what error would be generated. So FIFOs and LIFOs. So they call it pop modeling, which is another good term. So they're calling it push and pop. Pop's not the name you call your dad. Somebody wants to call your dad. Pop. Okay. Okay, now we got to pick, we talked about the index register. So we got another register that we're going to use as a, what we refer to as a stack point. Where's that guy at? No, it's not a status. It's what you can use whatever register you want to. The FIFO operation, first item in the stack is the first item one. The last in, first out. We've already established this. Is that okay? So when we use the term push, we mean we're going to do what?
That's all the stack.
And here when they use the term pop, it means we're going to do what? Okay. Okay. Yes or no? So these are our instructions. So we use 2 to push information on there. We use 2 to pull information off. So here's our 4 instructions. So FFL, this would be a what? This would be a push. FFU, this would be a what? Pull from a FIFO, okay? LFL would be what? Push on LIFO, and LFU would be what? Pull or pop. Everybody okay? Okay? Yay? Nay?
So load means push and unload means pull.
Yeah. I don't know if this came out, this come out of the book.
This gonna be on the test, pull or pop.
You can't use one without the other.
I'm talking about
In the middle, you said you use pull or push.
Huh?
Are you gonna, he's saying that you're gonna use push or pop, or you gonna use pull or push? Pull or push. Unload or unload.
What could I be, what could I use?
Load, unload, push, pull, push.
Thank you,
Is it gonna be load or unload, or is it gonna be, or is it gonna be push and pop?
I'll say yes.
Okay. All in
Yeah, and what we're saying is that, if you're in a trade, if you're in a trade that uses different words to explain the same thing, and by George, you need to do what? You need to know the words. And they all make sense, Josh. Don't it? I mean, they're pretty much explanatory whatever term we use.
pull and pop the same.
Yes. And
Pull and
why?
pop off the stack. Because you're unloading the stack.
Yeah. So what we're saying is no matter which term is used on the test, you should be able to know the difference between each one's which, right? One of them's going to put information on the stack. The other one's going to get information off the stack. Whether we use the term load, whether we use the term push, I guess we could use the term store, yes. You know, store information on the stack, we could use that term too. Those terms.
Well, let's look at the example in the book. In the PLC, the stack is created when the stack,
So all we got is the stack point. It's not like the index register. The index register is fixed. So that means if you're using index address, by George, you're going to be using S2 colon what? 24. The only thing that's specified about the stack pointer is it's got to be an integer register. So it's got to be one of your what? N7. You set up the stack. You set up the stack pointer.
PLC system stacks are created when stacks are integer words, double byte words. Double byte, of course, Allen Bradley don't call them double bytes, they call them what?
Double
Windows calls them double words.
Yeah, long word.
Long words, yeah. Allen Bradley calls
Long word.
no, these are double bytes. These are double bytes. What do they call these?
Sorry.
32 bits would be, yeah. So this is another thing, this is the PowerPoints that came with the book. So they take double byte words, but that would actually be a what? A word. Data can be transferred into a register or another memory location from the stack. Everybody okay? So here we got a program, this should be in the book, got a counter. I've got to count up, got a preset of 1,000. So they're going to push 1,000 bytes somewhere. We're going to take information, right?
Well, what information?
Wait a second. What, Quinn said?
You said we're gonna do something to the information? I heard 1,000 bytes.
Yeah, we got a preset 1,000. We're going to use the counter accumulator as the source. Now these are going to go from numbers from. So the source that we're pushing on it is going to be setting up a first in first out stack using R6 as a control register. And we're setting up a link group.
So if you're using the accumulator at first in, first out, what's the difference in doing it this way or just using the counter?
Where's that instead of getting the certification for L1, for level 1 for the civil certification. They was telling us how they have a control line. Yeah. You know, I know it now. I said, why do they do this like this when it could be done a lot easier? And the guy said, well, Richie said, they wanted to put as much stuff on this that somebody would ever see. So this is not an application. This is just a demonstration of doing it. So you're right. There's a lot. We could just take it. That makes sense. So that's what they're doing here. So they're just using this as a demonstration of what we're going to do. So what we need to do is figure out the parts of this. So we're setting up a stack. What's the FFL mean?
And first load.
But this is going to do what? Load it.
Yeah.
This guy right here is going to do what?
Unload.
Unload it. Well, I was wrong a while ago, guys. We're going to use what as the stack?
Okay.
We're using B3, right, with an also 0. You need to look at this and figure out what it is.
Okay,
Huh?
Maybe it's gonna end there.
Let's bring it up and see what we're doing. Huh? Let's bring this.
on the first in, first out, load and unload, do you have to use both first in, first out, or? I mean, would there ever be an application where you?
Well, the problem is what the stack pointer does. So normally, if we do a first in, first out, it's what the stack which way the stack pointer comes through. Does that make sense? So if we did a last in, first out, that means it's gonna offset from the stack, right? You understand? If I do a first in, first out, it's gonna offset from the stack plus this offset on how far we've gone. So normally, and if it allows you to do it, I mean, that's, and what I found out a long time ago is that if it's possible to do it, some engineer's gonna do what? Do it. Normally, we would pull them off the same way we put them on. So if I push them on as a first in, first out, I'm gonna pull them off as a what? First in, first out. But like I said, if the PLC don't give you an error and those two instructions are available, there's some engineer somewhere that's gonna do that. When I teach digital, some of the digital data we have gives us some inputs, and it says, it puts invalid down there. And then I could show them an application where some engineer did what? Use, because it's not invalid. The IC don't blow up if you do that, and it gives you a predictable response when you put one of those invalid inputs on there. So yeah, I'm sure if you could push them on there with a first in, first out. So first in, first out depends on which way it increments, right? You understand that? So yeah, I'm sure. But normally, if we put them on there one way, we're gonna do what? Unload something.
I know the software was created here.
The load and unload, I understand, enable, disable, done bit, what is an EM bit? EM.
Now we'll have to look and see, does it give you the bits that's available?
It is,
I mean, it's good, that's a perfect good question, but I don't know.
She said it's supposed to be enabled. It's not.
No, this is done.
No.
One of them is gonna be probably when we exceeded this, and the other is gonna be the other way, probably come the other way. So the books give you the bits?
No, okay.
What I'm saying, yeah.
In FFL, it has an enable bit in the first one. In FFU, it has an EU bit.
That's what I was saying.
What's up with that?
So what instruction we doing with the
FFL and FF, the
FFU?
load and the
No, that's
FIFO
in,
load and FIFO unload.
that's enable, unload, and
Got a EU in there.
FFU.
unload.
They doing it in the last, LF, and LF.
Yeah, it is, but I'm looking for the status register.
Count up.
So the book gives you,
Count up.
Yep, no, I see.
On a bit, right?
On the,
You said the counter should be CUT.
that's a really good question.
yeah, but look,
A little bit to the right of that count up.
EM is the empty bit is set by the processor to indicate the stack is empty.
So where's the table?
So
Enable,
let you know nothing's in there.
The DN bit is set by the processor to indicate the stack is full. So when it exceeds the size of the stack that you put in there. The EU bit is enable bit, is set on a false to true transition of the rung and is reset on a true to false transition. The EN bit is set on a false to true transition rung and is reset on a true to false transition. The first one is, for unload, and the second one is load. One of them uses bit 14, there's a status register, one of them uses bit 15. Now, what's nice about, the PLC is you don't have to know what actual bit it uses, all you have to do is specify these two letters, and, I understand. So, EU is for an unload, EN is for a load. So, EU is false to true transition of the run when we use a unload. FL, these are for what? Load. The done, so those are all right. So, probably when we drop down, so the first two should be on all of them. The EM and the EN should be on both of them. And then the EU or the EN is going to depend on whether it's an unload or load. If that's what it's showing in the book. And the book doesn't explain this. Can y'all see that?
Well, we see the symbols, I thought you saw that train.
I don't explain it, but just show the symbol.
So I'm gonna blow this up, guys, and that way y'all can get the explanation there. Can y'all see that? Normally they give them a chart. That's why I was looking for the chart. But this actually gives you the explanation. I think we got some programs that we'll show y'all next class where we can play around with these. I know it gets a little simpler if you can actually see it applied. We could lecture on this all day long. See if there's any actual logic programs that we have available. I don't think there's much more left in this chapter. So what we're going to do, guys, is we got 3 weeks. So what we're going to try to do is just finish up the lectures and then be in lab the rest of the semester. Does that sound? So instead of breaking up, because usually we come down to class and then we go to the lab and then it takes us about 15 minutes to get going down there. And that way we can just be in lab. Maybe y'all can get some of these out. Y'all need to start looking at trying to go ahead in the labs and do some of these on logic. Okay. I know some of them are homework. Some of y'all are really, really behind on the labs. What you can do, we don't have Logic Pro on our computers, but we'll have to see it run. So if you put your Logic Pro, I've got Logic Pro on my computer. So if you want to do some of these labs at home, bring them in on like a USB thumb drive, and then I'll check them out on my computer. So we get some of these labs done. So some of y'all are really way behind. But, so I'll make that available. Also, there's another thing we need to talk about. We got certified during the break. We came out here we was in meetings on Monday, Tuesday, Wednesday. But we got certified to offer y'all a meter service, and it's free. I'm using a digital meter. Most of y'all have been using one for a while, but what you actually do is it's a Snap-on certification, and it's free. So we was trying to look at, but even though you know a lot about meters, odds are you still wouldn't be able to pass it unless you set through the lecture. Probably take about, we can go through them real fast, because most of y'all have a pretty good deal with meters. We might try to do it on a Friday, 4 hours on a Friday, if y'all want to come to that. To get the certification, you have to take the test. But if y'all wanted to look at a certification that's free, the Siemens certification costs you about $150. The ETA certification, when you get ready to graduate, you might look at that. That's the Electronic Technicians Association. It's a national certification. It costs about the same to take the test. It's about $150 to take the test.
One thing I was going to ask when I was I hadn't registered classes, but looking at the classes at the moment, there's one called Robotics Project.
Robotics projects is basically a lab class. It's one of the
I've never
electives.
seen it before, I was curious.
It's one of the electives in the AUP degree. It's one of the requirements for the short certificate. And by the way, y'all need to also keep an eye on your short certificates. You could literally leave the program with 3 awards from your college if you do it right. So what we need to do is check to see if you qualified for the short certificate, any short certificate, see if y'all qualified for a long certificate, and then the degree. So you could end up with three pieces of paper that you could put on the degree. The degree.
Oh.
So we have every program's got a short certificate, which is around 26 credit hours. And then we have a long certificate, which requires more academics, but not all of them that you have to take for the degree. It's 54, I think it's 4 credit hours, and then we have the associate's degree, which is around 74 or 73 credit hours. So, if you want to, you have to come to my office. I can't run them off here. But what I can do in my office is I can give you a printout of how far you've gone for each one of these awards. So it would come up here and say, okay, I need to take this and take that, and you could actually graduate.
If you have those classes, they'll automatically give you those.
No, they don't give you nothing unless you apply for it, which would be nice. We had an instructor here that finished up his master's degree. His master's degree worked, but he knew he was going to go ahead and get his doctorate. So he didn't apply for the master's degree. He's no longer here. Because what happened is he was already working on his doctorate degree, and to teach in a science program, you have to have a master, you have to have at least a master's. When they checked his records, he found out he didn't have his master's degree. When he went in and checked, he was okay as long as he stayed in school. I don't understand. But when we went in and checked, the bachelor's degree had changed, or the master's degree had changed. He would have had to get the master's degree, he'd had to do what? Go back and redo the new master's degree because he never declared the award. So he's no longer here. He said, I'm not going to do that. He had enough time in to retire, so this is smart guy too. Computer science.
Oh, me,
You probably already matched them. You probably can already.
I know the orientation, so that kicked me off.
Not from the, oh, yeah. But did you take it? Like, oh. How many semesters? Just one?
And I got credit on they set my credit.
Well, sorry, you didn't have to take orientation. That means you got credit for something. Orientation's in every award, every award we got. Probably need to check and see if, go look at your transcript and see if they give you credit for that. If you've had a lot of psychology, you need to go down there. Because if you hadn't had that, if you don't have credit for that class, we can't award you that.
What Friday were you gonna do that,
Don't know, that's what we gotta do. We gotta talk to my rest of the class, we'll try to do it on, we'll not do it on Friday, we'll probably try to do it before the end of the term. And like I said, guys, it's a certification that will go on your, you got a piece of paper, you know, you can carry in, say I'm certified on using
It was just about 5 questions.
Oh, about seeing what, yeah, I won't be in there until Friday.
Yeah, you got that?
Yeah, 8 o'clock.
No, I'm saying I just turned off.
Oh.
What's the, someone was telling me it's a orientation, it's not the full orientation.
They have a stripped down version, there's an online version, they do it for people who transfer in, but they don't have that grade. Which basically transfer students. Might look at that one, it's a strip, you're right, it's a strip down. I think they live off all the Blackboard stuff and all that kind of stuff. So I think it's online. So if you can't get credit, you might ask about that.
That's the one I did. In fact, they told me, I used to think They said that, so they said I was supposed to.
Well, the problem is, they degree, they won't, so that, you wouldn't be able to get your degree unless you get that taken care of.
You gotta have all
Even
those
if you
square
gotta,
schools.
even if they say you gotta take it, you need to take it. But if you took more than one psychology, which most universities, if you go for a bachelor's degree, you're gonna take more than one psychology.
I remember having psychology at humanities.
Humanities, we require
Man,
1 3 credit out of 4. Go
science.
down there and talk to the admissions and say, can I get credit for this? It's not up to me to get it, but they can get it to you. They can look at your transcript and say, okay.
I think I took psychology here at Lawson one
But
summer.
there is a psychology required, so they couldn't give you credit, dual credit. So if they gave you credit for the psychology you took here, then you can't use that same, credit for orientation.
It would be one.
But if you had 2 psychology classes, then they would probably give you credit, especially since you've been here for a while.
Oh, geez, I didn't think that was scratched out, but that
You
was.
need to get taken care of, son.
That was.
Because we can't even give you I can't even give you a short certificate. So that's on the certificates, that's on the long certificates, and that's on the
Right,
degree.
right.
Oh, yeah, it covers
But
all.
Nancy trying to work on the, what's it called? I'm trying to get credit for class.
What are they?
Oh, yeah, that, learning experience.
Yeah.
Yeah, she called it something, advanced learning.
Yeah, and so I gave her all, cause I was in that class with USD, and then, I was with you. I came down there and gave her a piece of this, Joe Nancy, when I came to USD. Stuff like that. So basically, those are the classes that I'm waiting on. Then I'm out of it.
For the intro class. Well, what you need to do is go down and talk to Jeff Shelley or somebody down in admissions and ask them about that class. And find out if they're gonna make you take it. And if they're gonna make you take it, you do
Well, I'm on a degree plan, it's not checked off, so
Yeah.
it's showing that I need it.
But just because it's not checked off, back in the back, you probably got a lot, and they can go back and look at your transcripts. It's just that they didn't see anything or they wasn't looking for that. But you need to go back and check and get that thing out of the way.
Well, that's what the next semester, I said, well, I was gonna take, if I gotta take on,
Like I said, they got, like you said, they got one for transfer students. You know, and you've been using Blackboard and all that other kind of stuff, and you might be able to take that one.
I had, what's it called too, what's the